placing the components is a very difficult task. So why we are saying difficult task is, at one point people doesn't even show interest in placement because it's a very hectic task, and PCB layout engineers who have experience can explain this much better to you. Because what happens is, the role of PCB layout engineer is not just routing between the components, right? He has to understand the placement requirements. Like simple example, if you have a IC here, okay, and there is a decoupling cap for a specific power pin of this IC. The decoupling cap must be placed as close as possible to the power pin of the IC. Very simple rule, right? It's a basic rule. Now these kind of rules, the generic rules we mean to say, are very easy to follow. But let us assume there are other rules which can be understood only by understanding the design, only by going through the data sheet. So these are very typical things which either designer must explain to the PCB layout engineer, or PCB layout engineer has to explore by himself to get to know such rules. Now, one point which we want to talk in this specific video is, now let us assume the placement is done on a PCB. You are seeing a simple PCB layout. Let us inspect the length and width here. So this is 25 mm, okay, and this is 35, okay, 25 cross 35, simple PCB, right? So now in this PCB, we have not more than 20 to 30 components. This itself, if you are a beginner, you might feel little hectic. And you see the components here. When you see this in 2D, you will find it very difficult to identify whether they are placed properly or not, whether any component is overlapping or not. It's very difficult to understand, right? That is why we have a 3D view in that is provided by the tool manufacturers or tool distributors, whatever. Any tool you see, you will have these kind of options available, and especially 3D is a very important option and a very useful option to get to know what is happening in the PCB. Now in KiCad, let's use that 3D option and see how the components are placed in this specific PCB layout. We kept it little clumsy to help you understand. Okay, we'll know from the 3D layout. Now click on view here. Okay, you can see here in view there is something called 3D viewer, which shortcut is Alt plus 3. So click on 3D viewer and it opens the 3D view of the PCB. Right now we don't have the 3D of the components placed. We only have for the discrete components, the passive components, and these components came from library. So any component that we added newly, we didn't have the 3D view of it. That's why you don't see any components. But this view is enough for you to know what you need to be adjusted in the preliminary placement, and how to make a beautiful PCB layout. Now if you can see here, this particular C1 and C2, the ref des of this is being overlapped by the button, so you might have to move C1 C2 here, and then you can also see here the R5 R6 are little overlapping, and C6 has to be adjusted, and if required C3 might have to be placed a little towards or underneath this, moving this gap a little. Okay, so again, one point to remember, electrical performance is very important than the silk related visual view. Now in case if you feel you cannot, let us assume you cannot move C3 either here or there, and you want to have the component to be moved towards this C5 to be moved towards right side to accommodate C3. You can also take a call on completely eliminating C3 from the PCB. There is no rule that you must have the ref des indicated on the PCB. You find many PCBs, that too dense PCBs, without the ref des printed on the screen. That is to save space and increase the component density on the board. So in such cases, you can take that call, and generally the assembly drawing will be used by the designers to get to know the component reference, or one can open the PCB layout and check the components. So the 3D view, right, here is giving us a very beautiful view of component placement, and you can adjust your components accordingly. And observations you can make here. So C6 is close to this pin, whereas this particular IC decoupling seems to be missing. Even these kind of things you can understand from this view. And you can also see here the J1 and J2 little seems to be offset from the edge. One of the important aspect of PCB layout design is the aesthetic. The aesthetic view is very important. Like for example, someone might want to have this particular USB connector, type C connector, at the center of the PCB. Okay, that is a very important aspect for their design. But if you are doing a design and you don't need that aesthetic view, you can place it here. But some of the things like this headers, right, Berg headers that are provided, these headers need to be aligned hole to hole, from the edge of the pad where the component starts. That means the center of this component must match with the center of this particular component. And sometimes even the orientation of this particular components is very important. Like example, if you move this component such that it aligns with the center of this, the look and feel changes. And then if this is aligned with the center of this particular regulator, the look and feel of the PCB will be different. So these aesthetic points, when actually you get the PCB and you start manufacturing the PCB, assembling the PCB, and once you have the assembled board in hand, you will feel these aesthetics. So these aesthetics are very important. Okay, so a clear understanding, right, of where to place the components, and this particular 3D view is helping us a lot. So this 3D view can be used to see backside. You can also get to know by using this particular icon here, and you can also move back to the original view. Okay, see, the component, the board looks cool, right? So you can also twist it to different angles by different options that are present. But for our discussion, as the top and the bottom placement we are looking at, we did not look at bottom much because there are only passive components. And one thing you see here, R3 is far away from the actual component. Okay, this is one important observation. And we have to ensure that C4, whatever is there, okay, as it cannot be accommodated at this juncture, it is placed on the bottom. So ensure that it is very close to the respective pin. So these are the observations which can be made using the 3D view, and very helpful view, right? For beginners in the PCB layout, this is very important. Thanks for watching our video. Subscribe to our channel. Please keep visiting our channel YouTube. Where to know. Thank you.